All right, ladies and gentle people, it is a wonderful day to do some math, so let us hop into our next unit. Our next unit is solid geometry. So we are now graduating from two-dimensional stuff to three-dimensional stuff. So here's my terrible rendition of a cube, and this would be sort of a cone, an upside down like ice cream cone type thing, okay? So before we start talking about specific shapes, specific definitions and that sort of thing of shapes, we want to have a common language that we can start to use to describe all these different objects. All right. So those three terms are: we need a face. Face. Okay. So a face is a flat surface of a solid. And we can also have a curved face if our solid involves curves. Okay, so it's not necessarily a guarantee, but in general, a face is going to be a flat surface of a solid. So for example, we have a face right here, a face right here, and we also have a face down here. We have a whole bunch of other faces on these objects, but this bottom circular object, that would be a flat face. We could also say we have a curved face on this cone portion, the part that you would hold on to if you're eating ice cream. Okay, so we have some faces. Next, we want to talk about edges. So an edge is the line formed where two faces meet. Okay, line formed where two faces meet. So as far as edges go, we would have that would be an edge. This would be an edge. This would be an edge. And then around the bottom here, this would be an edge. Okay. And then last, we're going to talk about vertices. And this is the point formed where three faces meet. I guess I should say three or more. Three or more faces meet. Or the point of a curved surface, or curved face. So this guy right here, where this face, and this face come together, is a point, or is a vertex. If we're talking about one of them, it's a vertex. This guy right here, where this face, and this face come together, is a vertex. We have a vertex down here. Every single corner on this cube is going to be a vertex. And then we also have a vertex up here at the top of this cone, where that cone forms a point. Okay, so we have faces, we have edges, we have vertices. Okay, those are our definitions that we're going to use when we're talking about solid objects. And different solid objects will have different combinations of faces, edges, and vertices. Okay. So first thing you might want to first solid we want to know is a prism. Okay, a prism. So a prism is formed by two parallel bases. Parallel by two parallel and congruent polygon bases. Okay, two parallel and congruent polygon bases connected by faces that are parallelograms. Okay, so this is our formal math definition. All right, a prism is a solid that's formed by two parallel and congruent polygon bases connected by faces that are parallelograms. So for example, if I have a triangle here, and it comes straight down to a congruent triangle, all right, so something like that would be a prism. Or if you have a rectangle, all right, and then that rectangle, we have a prism. So we have a rectangle prism. So prisms are named by the shape of their bases. Prisms are named by the shape of their bases. So if a base is a triangle, like this, then it's a triangular prism. If our base is a rectangle, then we have a rectangular prism. You can have pentagonal prisms. You can have hexagonal prisms. You can have whatever agonal you want, as long as the top shape. Let's see if I can make a pentagonal prism happen. And then as long as the top shape is congruent to the bottom shape, that is a prism. Okay? Connect two parallel and congruent polygon bases connected by faces that are parallelograms. All right. Famous prisms are the cube. Okay, a cube is a rectangular prism, but instead of just being all the sides just being rectangles, now we can say that all sides are squares. So we can say that this length is the same as, if this is length 1, 1, 1, 1, all the edges are all the same length. Okay, so we have all these guys that have faces, edges, and vertices. These are your prisms. Two parallel congruent polygons connected by faces that are also parallelograms. Those are your prisms. Okay? The next group of shapes that we want to know are cylinders. Very similar to prisms, but cylinders, instead of having polygon bases, they have circular bases. Let's see. So we have two circular bases that are parallel and congruent that are connected by a curved face. Okay, two circular bases that are parallel and congruent connected by a curved face. So if I take a circle, lay it down, I get that shape. Then we bring this down. Make sure you have some of these sketches in your notes so that way you have something to refer to when we are trying to talk about these in general. All right, so again, we have our faces. We have our faces here and our face down on the bottom. We have two circular bases that are faces, and this is our curved face that wraps around the side. We have our edges around the top and around the bottom. A cylinder has no vertices, has no vertex. So that's something to keep in mind about a cylinder. All right. So we have prisms, we have cylinders. So the next shape we want you to know about is a pyramid. A pyramid is an object that has a polygonal base, so a base that is a polygon, and triangular faces extending off of that base that form a vertex. So something like this, where you have a rectangular base and we have some triangles coming off of here that all meet to form a vertex, and that was a garbage drawing. There we go. Not much better, but it's the best I got. So we have a polygon base and triangular faces that form a vertex. So the name of the pyramid. So any pyramids that have a name, are named for their base. So here we have a triangular pyramid, and you can make whatever polygon is forming the base. Gives you the name of your pyramid. So triangular pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, whatever shape you have on the bottom, you get that as your pyramid name. So the next shape we're going to talk about is a cone. A cone is a solid that's formed that has one circular base and a curved face that connects that base to a vertex. Okay, so that would be something like this, where you have a circular base that is a face of your cone. Then you have a curved face that connects the base to a vertex. We have a vertex down here, and then we have one edge going around our cone. Okay, so these are 4 different shapes that we want you to know that you kind of just need to be able to recognize and be able to identify. So let's take a look at some shapes, at some real-life objects, and see if we can classify them into their group. There's still one solid that we haven't talked about. We'll talk about that particular solid later. But for right now, let's just talk about those 4. All right? Hang on 1 second. All right, take a second, and I would like for you to try to classify each of these by using each of those 4 definitions, each of those 4 terms that we just used. Take a second, pause the video, see what you can come up with. All right, here's hopefully what you came up with. Figure that has an edge at the top. Yes, I would like to use the light blue pen, please. So a figure that has an edge at the top, an edge at the bottom, a circular face at the top, a circular face on the bottom, and then a curved face with no vertices is a cylinder. This guy is a cylinder. This guy over to the right of him, this guy right here, this guy is circular face at the bottom, curved face connecting to a vertex. This guy is a cone, which it's a traffic cone. Hopefully you came up with the idea that it's a cone. Down here we have a rectangular base at the bottom with triangles connecting off of it up to a vertex. This guy is a pyramid. And more specifically, it's a rectangular pyramid. And then this last one is not only delicious, but has a hexagon on one face, a parallel and congruent hexagon on the other face, and then a bunch of parallelograms that are connecting it. This is a prism. More specifically, a hexagonal prism. All right, but one kind of neat thing about the Toblerone, if you zoom in on it, you can see that this is actually 6 candy bars in one. So we have a triangular prism going all the way back to the other end of the triangle, and we've got a bunch of triangular prisms making up this larger hexagonal prism. Okay? So, we want to be able to classify objects by their solids by their type and definition, and we want to be able to pick those out at will. Okay, so that does it for today. Um, Keep an eye on Classroom, and we will let you know what is coming down the pike. Have a great one, guys. Bye.